today, or rather what I'd like to do is, so I want to start off with, since many of you still on Exchange 2010, let's talk very briefly about the differences between 2010 and 2016. Now those of you who are moving to 2013, it's 2016 and 2013 are very similar, and so a lot of what I'm talking about will hold true for 2013 also, except for the fact that if you've attended any of the other Exchange sessions, you know all components are on one box. There is no cafe anymore. It's all one box, the mailbox, right? So apart from that, though, a lot of similarity. We'll go into deep dive for each of the transport components that ship with Exchange 2016. We'll go through a few routing scenarios so you understand at the end of the day how routing will work with both 2013 and 2016. It's very similar. Transport high availability, and finally Office 365 mail flow. So what's the major difference between 2010 and 2016, or even for that matter 2010 and 2013? Now, if you remember in 2010, when you have mail coming in from the internet, it uses SMTP to talk to the hub. The hub, on the other hand, talks MAPI when it writes to the store. Now, you'll notice that, and I'll repeat this, keep repeating this, the hub and when it talks MAPI, there are two different machines here. So MAPI is actually going across machines. That is changing in 2013 and 2016. Now, to illustrate that point, so let's talk about the other hub receiving SMTP traffic in this case. That hub will send mail to the hub in the site where the mailbox is, and that hub will make a cross-machine MAPI write for that mail item into the store. Okay, so that's how 2010 in general operates. Now, if you are familiar with MAPI, MAPI in itself, I mean, it's a robust protocol, but when you talk about cross-machine, not so much. Even if you people have akin that to, for instance, opening File Explorer. You open File Explorer on your box, it works almost always, rather. You open File Explorer to browse files over the network, you know, it's mostly good, but sometimes not so much. And that's why in 2016, you will notice, as well as 2013, if there's one takeaway you want to make from these first few slides, it's that there is no cross-machine MAPI communication. Okay? All cross-machine communication will happen over SMTP, which is way more used to cross-machine talk. So I'll briefly highlight the components in 2016, and then we'll go deeper into it.
I'll go through it, and I have that.
You'll see that there are three components, in this case all shipping on the same box.
Thank you.
Not the case in 2013. You do have a cafe box in 2013 that has the front-end component. So you have three components: the front-end transport, and mailbox transport. Mail comes in via SMTP, always hits the front-end transport first. Okay, it doesn't matter whether it's on the mailbox server or on the cafe server, it always gets hit first. The front-end transport service will then talk SMTP to the transport service, which will then talk SMTP to mailbox transport, and mailbox transport is the only component that will actually talk MAPI locally on the machine. Now here everything is local, so that's good, but what if the mail came in, for instance, on the other front-end transport box? So it comes into front-end transport, and we'll be reiterating this a lot. So if you can't catch me this first one, you know, at the end of the session, I'm sure you'll get that.
Awesome.
So anyway, mail comes in via SMTP to the other box in this case. Front-end transport talks to transport on the local machine. Now this service realizes that the mailbox actually exists on a different machine. So it will go cross-machine from transport to mailbox transport, not directly to the store via MAPI. It will go SMTP from transport to mailbox transport, and finally mailbox transport will talk MAPI locally. So you can see the big difference between both of these is MAPI is local and it's all cross-machine traffic is SMTP. We'll be doing more of the routing on 2016 a little bit later. The other thing with, I don't know about you guys, but debugging SMTP is much easier You look at the protocol logs, you look at the stuff, it's just, it's easy to understand the talk that goes on between these machines versus mapping. Okay, moving on, so that's the big takeaway here. So we spoke about delivery. Let's give an overview. This is only an overview. As I said, we'll go into details later. What happens when mail, in 2010, what about submission? So you write a mail, you compose a mail, you press send. That mail, you get a notify MAPI call. The submission service gets a notify MAPI call. And the hub, again, talks MAPI cross-machine to get the mail item and communicates via SMTP outside. In 2016, on the other hand, the mailbox transport locally will again make a MAPI call, get the mail item, and then make a SMTP call to the transport service. It usually picks the transport service in another box for redundancy reasons. So it'll go to a transport service on another box, which will then send that mail out via SMTP. So again, the concept is really the same, both submission and delivery. The difference is cross-machine traffic is always going to be SMTP, and locally is mapping. So so the three components that I'm going to dive deeper into right now in the next slides are front-end transport, transport, and mailbox transport. So of the three components, the transport service is the only service that is stateful. Now you might equate the transport service to, we used to call it hub transport to some extent in 2010. So it's similar. It's the same thing really. So you have front-end transport, you have transport and mailbox transport. One takeaway: transport is the only stateful component. It's the only place where your mail will be stored. Nowhere else, no other transport component stores that. Transport responsibilities remain unchanged. We receive and deliver all inbound mail to the organization. We submit and deliver all outbound mail to the organization. So inbound, outbound, that's our responsibility. We perform message processing, finding out routes, expanding distribution lists, and so on, and we'll talk more about that. Finally, we also have extensibility points built into the pipeline, where third parties can leverage those extensibility points to do things like processing the mail or changing the route of the mail and so on. And finally, and I'll go deeper into this, is we will keep messages redundant much better than what we were doing in 2010. So that's the other big difference. Front-end transport. Now, front-end transport receives mail on port 25. Anonymous mail on port 25, authenticated mail on port 587. So if you were to connect to smtp.contoso.com, for instance, depending on which port you connected to, you would go to it will either accept anonymous or authenticated mail. In authenticated SMTP, you're talking about the client or the sender having to provide a username password to authenticate, much akin to folks doing client submission. I don't know if you have Thunderbird or one of those clients, that's using client submission via port 587. So the one change that has been made is that now we support TLS 1.2 in addition to 1.0 and 1.1. That shipped in CU 8, I believe, for 2013. So even 2013 gets TLS 1.2, as well as 2016 will too. The other thing to keep in mind with front-end transport is that on the way out, mail on the way out, you don't have to go through front-end transport. The transport service can send mail out, but in some cases people prefer to actually have the symmetry, so mail basically goes out via front-end transport just as it came in. To do that, you have to set the front-end proxy enable parameter on your send connector. Now, in terms of benefits of front-end transport, the primary thing to keep in mind, the primary role the front-end transport possesses is it looks at a piece of mail and finds the mailbox associated with that mail. When I say mailbox, I actually mean DAG. It finds out which DAG that user is in. And based on that, it will connect to the right transport service. And we'll talk about that a little bit more. The other thing is obviously, it scales with the number of connections. I mean, you can send as many connections as you want. It'll spawn off new connections. It can go up to, I think, about 5,000 by default. Finally, it also supports SMTP extensibility points. So there are a bunch of extensibility points built into every stage of the SMTP protocol on ELO, on Connect, and you could have either third-party agents or write your own agents to hook into those points. All right, let's move to probably the core piece of transport here. We're talking about the edge transport.exe or the transport service, or previously known as hub transport, as I said. Most of you are familiar with this. One thing to keep in mind is because the front-end transport service is taken over port 25, it's the same box, the transport service will look at port 2525 for its SMTP mail, all right? And it will accept mail from both the mailbox transport service, you can see that on the bottom. It'll also accept mail from the front-end transport service. Oh, I can only do this on one of the screens. Okay. Finally, let's go to the next slide to talk a little bit more in depth. I mean, you know the drill in terms of we would accept mail both from outside as well as via port 2525, as well as if you put a mail item in the pickup or replay directory, we would pick that up too. Now the next slide actually has more details on what happens in this pipeline. So I have a piece of mail here that's coming in. One thing to keep in mind is that we will only accept mail or return back a 250 OK to the sender once we have saved a copy of that mail. So the first thing we'll do is that copy of the mail is actually saved in the mail.q database that is on the box. So mail comes in, gets saved there. Now that if we have a copy, we are ready to process it. That piece of mail will now get into the submission queue. The submission queue is where all incoming mail comes. There's only one of it. I think it has a limit of 10,000 messages or so. But mail comes into the submission queue, and it goes to this categorizer pipeline. A lot of good things happen in this categorizer pipeline. Let's walk through this list. So the first thing that we do when we get a piece of mail is we look at the recipients on that mail, and we resolve them. When I say resolve, I mean we will look up Active Directory, find out whether this is a mailbox. In some cases, it's a mail user or a mail contact. If it's a distribution list, we will find out that it's a distribution group, and we will expand membership for that group. All of these things happen at the resolve event. We would also convert things like convert from alias to primary address. That also happens during this phase. If there is a forwarding rule present, we would use the resolve during the resolve event. That's when we'll determine that this mail needs to get forwarded to another mailbox. So that's what happens. We resolve the recipients first. So now we know what we are dealing with, who they are. The next phase is to actually determine the route for these recipients. Some of these recipients have mailboxes on premise. Some of these recipients are external recipients. You could be sending a mail to somebody at Yahoo at the same time to your own or somebody else in Contoso. Those routes are figured over here. So when we figure, and in some cases we are going to be applying send connectors at this point, determining where to send that piece of mail. And in the last stage, that's when we would do things like, okay, this piece of mail is going to 2 recipients. We need to send one copy of the mail here and another copy of the mail there. We need to put the right addresses. We would also need to make sure that if you're sending mail outside, if the remote domain supports does not support TNEF, supports MIME, that's when we will convert the mail into a protocol that the other side understands, or format that the other side understands. All these things happen at content conversion and bifurcation during that step. Now, you have seen that during this entire process, there are like 4 lollipops that I've drawn there. Those are the extensibility points inside the transport service in the pipeline. Different agents subscribe to different points based on their needs. Sometimes some agents subscribe to multiple points. So, for instance, on the on-submitted, you have anti-malware usually is the first thing that works. As soon as it comes in, that is taken care at the on-submitted stage. Before anything else is processed, it can be thrown away. That mail can be thrown away if it contains malware. The transport agent, for instance, even before that, the journaling agent, the unjournaling agent would probably work, or the decryption agent also works, for instance, at the on-submitted stage. At the on-resolve, once you've resolved the components, that's where things like the transport rules go into play, because they deal with recipients once they're resolved based on the rules you have. After that, you're talking about on-routed. And during on-routed, again, you have instead of the unjournal agent, you have the journaling agent, for instance, that works on the routed, as well as sometimes you might need to change rules based on SMTP forwarding. That might also override the route that the mail is actually going to be taking. On categorized, I don't know of too many agents subscribing to that, but at the end of the day, that's the event available in case you want, after the whole categorization process is completed, you want to look at that mail item, that's your event to look at. Now, one thing to keep in mind is we only had one submission queue, but we have many delivery queues. Okay, these delivery queues, there's a delivery queue per destination. So if mail is going out to Yahoo, you will see a delivery queue for Yahoo. If it's going out to Gmail. If it's going out to mailboxes, you'll have different, depending on which database, because a mailbox can have multiple databases. Depending on which database it's going to, you will see a different delivery queue per database. So it's destination based. And so in this example, this piece of mail of mine, one piece of mail is going via the mailbox delivery queue to be submitted to the mailbox transport process, or sent to the mailbox transport process to get submitted, or get delivered rather. And the other piece of mail is going through the external delivery queue, also to be sent out, in this case, to some external destination. So that's kind of the general outlay of what the transport pipeline looks like. So just a quick recap in terms of the advantages here, or the benefits. All routing decisions take place inside the transport service. It is the place for extensibility. Most third-party agents actually hook up to extensibility points along this pipeline. The other thing is it protects messages by making a shadow copy, and I'll go through much more detail about that in subsequent slides. What about the mailbox transport process? The mailbox transport process, it's called mailbox transport, but it's really two services on the box. You have the MS Exchange delivery service, and you have the MS Exchange submission service. Both are separate processes on the box. The delivery service is used to receive mail from the transport service, and then call MAPI to write that mail item to the store. Now, it receives mail on port 475 on that box. It also does any MIME to MAPI conversions. Now, one thing to keep in mind, you might notice there is actually a SMTP send component inside the delivery service, and you might be wondering why that is there. The reason for that is when you're trying to make a delivery, inbox rules act on the mail. Sometimes you have OOF messages that need to be generated. Those messages go out via the send component. Let's move on to the MS Exchange submission. Now, the submission service, it subscribes to the event infrastructure service, or the event assistance infrastructure service, like many other event assistants. What I mean by that is, when you click the send button, you'll notice that the mail actually goes in your outbox first if you're using Outlook, or it goes into the drafts folder if you're using OA. What's really happening is the store is now sending us notification saying, hey, I have an item to send, I have an item to submit, I have an item to submit. And the submission service is the one that picks up that item from your outbox and then calls SMTP to send it to the transport service. So if you ever notice that, hey, users complaining that their mail is stuck in their drafts folder or in the outbox sometimes, it could quite possibly be the submission service on the box is not running. So these two services are very critical because they have direct user impact. User can perceive that. Because when you are trying to send a mail and the other person does not receive it and it's in your outbox still, that usually signifies, outside of Outlook issues, which are quite a few to discuss here, but outside of Outlook, the submission service is quite likely the reason why it's either stopped on the box or it's hung and so you cannot send mail. The delivery service is equally important because if delivery service is not running on the box, people aren't getting their mail delivered to their mailboxes. They can't see their mails. Mail is most likely getting queued in the transport service. This component does not support extensibility, by the way. And the primary thing that and I keep repeating this, I'll say it one last time, is that the reason why this service is there, the mailbox transport service, is to be the component that talks MAPI. Okay? All right. Now let's move to somewhat of an architecture diagram. You probably have seen this before in some other sessions too. We have on the right an enterprise network. It is behind a load balancer. And you have, in this case, I've just shown you 3 DAGs with a bunch of mailbox servers in these DAGs. Each DAG, in this case, I don't know, I could have up to 16 mailbox servers. But there are 3 DAGs in this environment. And mail, basically, actually, before we go to that, one thing to keep in mind, the reason why I've drawn those dotted lines is because there's a load balancer or a WIP sitting in front of all these different front-end transport services, right? Any front-end transport service can get the first incoming mail, any incoming mail. Your WIP or your load balancer is just balancing between these front-end transport services. It doesn't really care which one it chooses as long as whatever mechanism it's using, round robin or whatever, it's going to send it to one of these front. It doesn't know where the mailbox resides. It just knows that it has a bunch of front-end transport services to send that mail to. So there are all these front-end transport services, one on each box. So when mail enters the organization and it enters it from the internet. Now I have drawn, some people have Exchange Online Protection, or they might have other devices or other services that they use for spam. But the mail comes in, this is coming in from the internet. And in this case, our load balancer has picked up the front-end transport service on this one box. Okay, so it has picked up one of them. It sends that mail to that front-end transport service. The front-end transport service, I told you, one of its primary duties is to talk to Active Directory and figure out which DAG that mailbox, that recipient belongs to. So it queries AD and finds out that that particular recipient belongs to DAG 3. Now it doesn't really care which mailbox server it sends in that DAG. What it cares about is that it has found the right DAG. So it knows it's on DAG 3, and it will send the piece of mail to the transport service that's running on a machine in that DAG. It usually prefers the transport service running on a mailbox server in its site. Okay, so it'll prefer that, but it'll pick any mailbox server that's in that DAG. So it sends that mail to that transport server. That's where all the processing takes place, the categorization, and so on. And the transport service now finds out, when it does the resolution, that's when it finds out, okay, this mailbox resides on this particular mailbox server in that DAG. And what's it going to do? It's going to basically, within the DAG, it can talk directly to the mailbox transport service. So it'll send mail to that mailbox transport service, which will locally write to that mailbox. So that's kind of the overview of how mail basically flows inside the organization. Now, no, I guess talk would be complete without mentioning the edge role. The edge transport service, I'm not going to go into depth with it, but a lot of people still use the edge transport service. In fact, show of hands, how many people have edge transport running? Okay, fewer than I thought. Okay, that's good. That's good. I mean, I say that's good because I see fewer hands, and every year I see fewer hands come up, which is good. I mean, the reason why I say that is because, I mean, it's there, like its role is the same from 2010. It's the same in 2013. It's going to be the same in 2016. Role is that, hey, I don't want a machine that's attached to my Active Directory. I want a machine that's non-domain joined to accept mail before anything happens to that mail. That's the sole purpose of the edge transport service. While that is good, because it is in the DMZ, as you can see, what's not good is that it doesn't have any AV by default. It doesn't have any anti-spam features by default, no shadow copy. So if your edge role died after accepting mail, that mail is lost. The other thing that it does not have, I mean, is, well, actually those are pretty much the only things. But that being said, the no AV and scarcity of anti-spam means that box is getting bombarded unless you have something sitting in front of it, either some kind of anti-spam service or a third-party software that's running on the edge box. Okay. So, and one more thing to keep in mind is client submission. The last point there, client submission traffic. So, traffic over port 587 never goes via the edge. It goes directly to the front end transport service running on port 587. Okay, now let's go through some mail routing scenarios. I'm going to go through about 4 of them. This is the same knowledge that I had mentioned before, which is front-end transport's job is to look at the recipient. If there are multiple recipients, so actually let's start from the top. When you get a mail item, piece of mail, it could be to 1 recipient, 2 recipients, 10 recipients. Front-end transport will always anchor to just 1 recipient. So it'll pick 1 recipient, okay? And it'll use that recipient to do its routing. So if it picks a recipient usually picks a recipient that's local, that's in the mail, that's basically in your organization, and it'll pick up that recipient, try to find the mailbox or try to find the DAG for that recipient, and then it'll send that to the mailbox server in the DAG. Oh, this is preferably the same site as the CAS box. That is 2013. So, all right. So let's see how this works. So you have one machine. Let's understand this. You have one machine that's a mailbox server. It has all the 3 transport components, and there's a mail item coming in for this person in purple. So front-end transport service receives this on port 25, determines which DAG, since it's the same, this DAG, there's only one DAG here, it will send the mail to the transport service on 2525, processes it, sends it via mailbox transport on 475 to the store. If you look at this sequence of events using the protocol flow, this is what it looks like. So you have from the internet SMTP server that's trying to connect to the front-end transport box. It goes through the regular SMTP protocol of an ELO, a 250 OK, mail from, receipt to, and then when it starts sending data, it's at this point that the front-end transport process has the recipient. It has to wait for the receipt to get the recipient. It anchors on that recipient, finds which transport service to talk to, and then establishes a TLS connection to that transport box and authenticates with it, and then sends this verb, this X proxy from verb, which is specific for internal exchange, which is telling the transport server where this mail is coming from. So the X proxy from, if you look at the protocol, would be something like this mail is coming from this IP address, this server, all the information that it knows, because the front-end transport is the thing that's actually internet-facing, that's actually talking to the server that's exchanging mail. Now, the front-end transport then transfers the mail from the receipt to and the data fields to the transport service. Once the transport service has received all that data, that's when it'll reply back with the 250 OK. I've now stored that piece of mail. That piece of mail is now my responsibility. And it will return back a 250 OK. Eventually, the destination or the sender will quit the connection once it has sent that mail item. Communication between the transport and the mailbox transport service looks like this. I told you it's SMTP now. What it's doing is basically saying, hey, now it's talking to the mailbox transport service that's on the box where the mailbox is. It's doing the regular ELO 250 OK or exchange auth command, so it's authenticating. And now there's this verb that's passed, which is X sessions params. And it's in this verb that we send information to the mailbox transport service as to which database this, what you call this user belongs to. So the mailbox transport service knows to open a MAPI connection against which of the many databases on the machine. Okay? So the transport service has already looked that up. It knows exactly where to go, which database. That's the information that's passed in the X sessions params verb. After that, it's the regular SMTP protocol, mail from, receipt to, data, and the connection closes. So this is the whole end-to-end flow if you look at it from internet to front-end transport to transport and finally mailbox transport. What about the received headers? Go quickly through this. That same piece of mail that was received from the internet, it has gone through it has actually been received on the same box by 3 separate services. That's why you will see 3 headers for that same piece of mail, even though it's on the same box. The first one at the bottom is via front-end transport, because that's what received it first, followed by just transport, followed by mailbox transport. So don't be surprised if you see, oh wow, why is this box receiving this mail 3 times? It's not receiving it 3 times. It's just moving through the 3 services that are on that box. Okay? All right, what about